This may be the most puzzling mystery in human history. The early rays of the sun were weak, yet life emerged on Earth. This seemingly counterintuitive question has perplexed astronomers for half a century. But what exactly is going on? As early as 1972, American astronomers Carl Sagan and George Mullen posed a crucial question based on existing stellar theory. The early sun wasn't as bright as it is today, with only 70% of its current luminosity. As a result, the Earth would have received much less heat. Theoretically, 3.5 billion years ago, the average surface temperature should have been about -7 degrees Celsius, leaving Earth completely frozen and unsuitable for life. However, fossil evidence suggests that life had already begun to evolve at that time. This contradiction is quite puzzling. If the early sun was so faint, why didn't Earth turn into a desolate, frozen planet? Instead, life emerged. This question shook the entire astronomical community at the time. One early explanation was that Earth was enveloped by a thick atmosphere of ammonia gas, which could have trapped enough heat to keep the planet warm and prevent liquid water from freezing. But soon, this idea was challenged since ammonia is easily destroyed by ultraviolet radiation. Scientists then turned their attention to another greenhouse gas, carbon dioxide. They theorized that early Earth, with its abundant volcanic activity, could have released enough CO2 to counteract the dim sun's effects. However, there were complications. High concentrations of CO2 could have increased cloud reflectivity, bouncing sunlight back into space and making Earth even colder. Without geological evidence, it was difficult to verify this theory's plausibility. Another hypothesis suggested that Earth had an additional heat source, tidal heating from the Moon. When the Moon first formed, it was much closer to Earth, and its massive tidal forces could have generated internal friction in Earth's magma, raising the planet's temperature. While lunar tidal forces played a crucial role, they weren't sufficient to fully solve the faint young sun paradox. Additionally, this further complicated the question of life's origin. Was the emergence of life on Earth inevitable, or was it merely a coincidence? In December 2020, a research team from the University of Southampton created a computer model with 100,000 planets, each with habitable initial conditions. They simulated planetary evolution under various climate conditions 100 times for each planet. The results were disappointing. 91% of the planets became dead worlds during their evolutionary processes. This means that if Earth's evolution were repeated 100 times, there's a 91% chance that life wouldn't appear. Does this imply that life on Earth was a mere accident? Looking back at Earth's 4.6 billion years of evolutionary history, it becomes clear how fortunate its existence truly is. While both Venus and Mars once had oceans, they are now scorching wastelands and frozen deserts. Only Earth, through its ideal position and stable environment over time, allowed life to emerge and evolve after a series of fortunate events. Although the faint young sun paradox remains unresolved, it has elevated our understanding of life and the universe to new heights. It continues to drive humanity to explore the vastness of space and reflect on the meaning of our existence in this boundless cosmos.